Mr. Ford here. This is going to be a continuation of the videos on the LEAP 2025 geometry practice test. This is problem number 38. A billboard at ground level has a support length of 26 feet that extends from the top of the billboard to the ground. A post that is 5 feet tall is attached to the support and is 4 feet from where the base of the support is attached to the ground. In the figure shown, the distance in feet from the base of the billboard to the base of the support is labeled x. So we are to create an equation that can be used to determine x, discuss any assumptions that you should be made concerning the equation, use your equation to find the value of x, show your work, or explain your answer. Enter the equation assumptions, answer, and work or explanation in the box provided. One thing I want to note also, when they make these illustrations, they're not always to scale. So keep that in mind, okay? So let me zoom in. We're just going to solve this for x. So we really only need to see this. We don't need to see those instructions. So first things first, we are given that this length from the post to the base is 4, and we know that this post height is 5, okay? Those are the two things we're given. I'm going to go ahead and note that this and this are both right triangles. So, since they're both right triangles, and this is a vertical line that's perpendicular to the base, this line here, then I'm going to assume that these triangles are similar, right? I'm going to take on the assumption that they are similar. So we have a length of the hypotenuse, and we're looking for a length of one of the legs. In the smaller but similar triangle, we have both the legs but not the hypotenuse. So the best thing to do would be to find that hypotenuse and then write an equation to solve for x. So first things first, a squared plus b squared equals c squared. We're going to use Pythagorean theorem, right? At this point, you should not need any tutoring on Pythagorean theorem, but in case you don't know it, the Pythagorean theorem states that the sum of the squares of the legs of a right triangle is equal to the square of its hypotenuse. So a squared plus b squared, that's the sum of those legs squared, is equal to the square of the hypotenuse. So our a would be 4 squared plus our b, 5 squared, equals c squared. 4 squared is 16, 5 squared is 25, equals c squared. 41 equals c squared, so we take the square root of 41 to get us a value of c. I'm going to leave it like that. That's perfectly okay. That's more precise than if you tried to do it, turn it into a decimal or a fraction. So I'm going to say, okay, now I have a side length of the square root of 41. Now I can set up a proportional relationship between the larger triangle, and let me use a different color for that. Let's say this orange. We can say this larger triangle, the base, and its hypotenuse, because since they are similar triangles, those would be proportionate, right? So now we have, and we're solving for x, so I always like to put x at the top. So x over 26, right? Because we have x and 26 equals our base, which is, if we're using s, we've got to use our base here of 4. It's equal to 4 over hypotenuse here, use a hypotenuse here, square roots. I don't know why it does that. It just takes itself and does it. So 4 again over square root of 41. Now we have the equation that we can use to solve for x. So you know what to do. Let's go ahead and use our butterfly method, right? 4 times 24, x times square roots of 41. So x square roots of 41 equals 4 times 26. X square roots of 41 equals 104. Then we take x square roots of 41 over equals 104 over, we're going to divide both sides by square root of 41. Those cancel out, and our x would equal 104 divided by square root of 41. So I'm going to go ahead and set up an equation or use my calculator to do this, all right? Because I don't want to I, I'm just going to use the calculator just because for the sake of efficiency and time, but we could conjugate this fraction. We could uh, uh, rationalize it by rationalize the denominator by multiplying both top and bottom by the square root of 41. Um, but it's easier to just go ahead and use a calculator at this point. So 104 divided by square root of 41. So I'm going to do in parentheses, oh, actually, 104 divided by, in parentheses, I'm going to do 41 square roots, close parentheses, equals. So 104 divided by, the square root of 41 was like 6.3, something like that. So this 16.24, that's going to be That's going to be the length of this base. This x would be 16.24. So x equals 16.24. Now, we could take that and check our work. Really, all you have to do is you just plug it in, but we would need to know the height of the billboard also. Or we could take those two values and find the height of the billboard by using Pythagorean theorem. If we knew this angle measure here or this angle measure here, we could solve using trigonometric ratios. But for now, this is all they're asking, right? Use to determine x. But I really like this problem because this is the type of problem you can anticipate. Oh, where did it go? On the LEAP test. And if you know how to set up equations and you know Pythagorean theorem, you could do this. You don't necessarily need to know the trigonometry, the trigonometric ratios, but it could help if you got in a bind. So that's number 38. It's a great problem. I really like it, and you can anticipate having something like this on your LEAP test for sure. Okay, for number 39, Marcella drew each step of a construction of an angle bisector. Part A, angle Z is given in step 1. Describe the instructions for steps 2 through 5 of the construction. Enter your description in the box provided. All right, so for this one, instead of trying to write this by hand and having some mess, I went ahead and opened up a text box. And this is basically I mean, your answers may vary, but if you were to look at it, um, you could type something like this, for instance. For step 2, um, if you notice, step 1, the angle and point Z was given, right? So for step 2, you can draw any arc centered at point Z, right? So that was that point where the vertex was. Okay. Then you would label the intersections of the arc and the angles. So label the of the arcs of the arc and the angles, point A and point B, something like that, right? Because that's what they have on there. Then for step 3, you would draw any arc with radius greater than half of angle BZA, centered at point A. For step 4, you're going to do basically the same thing, only this time you would do it centered at point B. So you draw an arc, uh, draw an arc, and you need to make sure it's the same radius as the arc you did in step 3. So center it at point B, right? Then you would label the intersection of those arcs from step 3 and step 4 as point C. And then the last step for step 5, you will draw a ray from the vertex Z, right, through point C. So let me see if I was typing and trying to write at the same time. For step 2, draw an arc centered at point, that should have been Z, point Z. Then label the intersections of the arc and the angles, point A and B. For step 2, or step 3 rather, I guess it's hard to type on this thing and try to read it. It's kind of small. For step 3, draw an arc with radius greater than half. Let me make this bigger. Of angle BZA centered at point A. Then for step 4, draw an arc with the same radius from step 3 centered at point B. Label the intersections of those arcs from step 3 and 4 as step C. As point C. For step 5, you will draw a ray from the vertex Z passing through C. All right, so done. And you can see that's basically what you're looking at, right? So if you follow along with those steps, from step 1, let me go ahead and highlight this so we can see what I'm talking about. Step 1, this is given. You're given the angle with vertex of Z, right? That's step 1. Step 2, you take your compass and you put it on vertex Z and you draw any arc, and then where it intersects those angles, those rays from the angle, you mark it A and B. Then from point A, you do another arc that's more than halfway, and you draw an arc here. Then you go point B, you do the same thing here, and where those intersect, you call it point C. Then from your vertex Z, you're going to draw a ray going through point C, right? So this is a pretty good illustration, and I really like the way that it breaks down the steps like that, because if you've noticed, uh, the book and a lot of these LEAP practice tests, they all deal with either angle bisectors or perpendicular bisectors. That's a big part of geometry these days. So I guess that's definitely something you need to commit to memory and something you need to understand and know. All right, so if you were to answer just like this type of question, you would probably get the most amount of points available for that question. So let's look at part B. There's a long space in between it. Part B, Marcelo wants to explain why the construction produces an angle bisector. She makes a new step with line segments AC, BC added to the construction as shown. So AC, BC, right? Using the figure, prove that ray ZC, which is the distance from Z to C, bisects angle AZB. All right, so be sure to justify each step of your proof. Enter your proof in the box provided. So this is one of those things. Proofs are very subjective, okay? And um, I, let me just give you what the answer key has, and we'll kind of go from there because I really think it's going to be hard for me to type it for one thing. So I'll just cut and paste, and we'll just kind of go over it to make sure you're understanding what is expected of you. So this is the example that's given as an exemplary answer for the for this particular question, right? And if you recall, so let me do this. I'm going to move this up so we can see it at the same time as the actual figure. Here we go. Line segment AZ is congruent to line segment BC, or BZ rather, and AC is congruent to BZ, right? So AZ is congruent to BZ, and then AC is congruent to BC. And it says both segments were drawn with the same compass setting and all radii of a given circle are congruent. All right, so that's not, this is one of those things about proofs that it can be a little confusing at times because it's really, as long as you're using theorems and postulates and you're using logic and reasoning, you can do a proof pretty much in any order you want to. You just have to make sure you're using theorems, postulates, and your rules and your properties and stuff like that, right? So number two, ZC. So let me highlight that. ZC is congruent to ZC, right? So, and that's because the reflective property of congruence. So if you're kind of missing what they just did, basically they said, okay, you have one side length here, you have one side length here, and then you have another side length here. So they're saying that that triangle that's being created is going to be congruent to this triangle here with that side length, this side length, and then this third side length as being congruent to itself. And then you can kind of see where this is going, right? So you have two triangles with three congruent sides. So then you would have triangle AZC is congruent to triangle BZC, and that's because of side, side, side triangle congruence. So then, number 4, angle AZC, that's this angle here, is congruent to BZC, this angle here, right? And that's because corresponding parts of congruent triangles are congruent. CPCTC. You may see this on the test. And that's what that means. Corresponding parts of congruent triangles are congruent. And then last but not least, line segment ZC bisects angle AZB based on the definition of an angle bisector, right? So what they're saying is, since this angle here is congruent to this angle here, let me zoom in. Since these angles here are congruent, then that means this line that goes through them, by definition, is an angle bisector, right? So that's basically what they did. They took the proof and they established first that the line segments that were drawn initially are congruent because you use the same radii, the same compass setting. Then you prove that you had two triangles that were congruent because corresponding, well, you have side, side, side angle, triangle congruence. Then, because they're congruent triangles, then you could say that angles were congruent, and then because the angles are congruent and there's a line or a ray that goes through them, then that tells me that it is an angle bisector. Okay, so that's a whole lot of stuff, and I know we haven't gotten much into proofs this year. It's just one of those topics that unless you do it early in the year, it's hard to get to towards the end because you have so many other things that you're trying to learn and try to get done. So that's going to be it for this video. There will be should be one more video going over problems number 5 and 12. I may split it into 2 videos, just depends on how long it takes. But this is wrapping it up with number 39. Two more problems, maybe one more video, and that's going to be it. And then you covered the entire LEAP practice test. As always, you know I love you guys, and I just want you to stay golden, my nuggets.